We have discussed how accidents are inevitable in complex systems, how they could propagate through those systems and result in disaster, and how organizational factors can go a long way toward reducing the risk of catastrophic accidents. We will now look at some practical steps that organizations can take to improve their overall safety. Red teaming. Red teaming is a term used across industries to refer to the process of assessing the security, resilience, and effectiveness of systems by soliciting an adversarial red team to identify problems. AI labs should commission external red teams to identify hazards in their AI systems to inform deployment decisions. Red teams could demonstrate dangerous behaviors or vulnerabilities in monitoring systems intended to prevent disallowed use. Red teams can also provide indirect evidence that an AI system might be unsafe. For example, demonstrations that smaller AIs are behaving deceptively might indicate that larger AIs are also deceptive but better at evading detection. Affirmative demonstration of safety. Companies should have to provide affirmative evidence for the safety of their development and deployment plans before they can proceed. Although external red teaming might be useful, it cannot uncover all of the problems that companies themselves might be able to, and is thus inadequate. Since hazards may arise from system training, companies should have to provide a positive argument for the safety of their training and deployment plans before training can begin. This would include grounded predictions regarding the capabilities the new system would be likely to have, plans for how monitoring, deployment, and information security will be handled, and demonstrations that the procedures used to make future company decisions are sound. Just as one does not need evidence that a gun is loaded to avoid playing Russian roulette, or evidence that a thief is on the lookout to lock your door, the burden of proof should be on the developers of advanced AIs. Deployment procedures. AI labs should acquire information about the safety of AI systems before making them available for broader use. One way to do this is to commission red teams to find hazards before AI systems are promoted to production. AI labs can execute a staged release, gradually expanding access to the AI system so that safety failures are fixed before they produce widespread negative consequences. Finally, AI labs can avoid deploying or training more powerful AI systems until currently deployed AI systems have proven to be safe over time. Publication reviews. AI labs have access to potentially dangerous or dual-use information such as model weights and research intellectual property, IP, that would be dangerous if proliferated. An internal review board assesses research for dual-use applications to determine whether it should be published. To mitigate malicious and irresponsible use, AI developers should avoid open-sourcing the most powerful systems and instead implement structured access, as described in the previous section. Response plans. AI labs should have plans for how they respond to security incidents, e.g. cyber attacks, and safety incidents, e.g. AIs behaving in an unintended and destructive manner. Response plans are common practice for high-reliability organizations, HROs. Response plans often include identifying potential risks, detailing steps to manage incidents, assigning roles and responsibilities, and outlining communication strategies. Internal auditing and risk management. Adapting from common practice in other high-risk industries, such as the financial and medical industries, AI labs should employ a chief risk officer, CRO, namely a senior executive who is responsible for risk management. This practice is commonplace in finance and medicine and can help to reduce risk. The chief risk officer would be responsible for assessing and mitigating risks associated with powerful AI systems. Another established practice in other industries is having an internal audit team that assesses the effectiveness of the lab's risk management practices. The team should report directly to the board of directors. Processes for important decisions. Decisions to train or expand deployment of AIs should not be left to the whims of a company's CEO and should be carefully reviewed by the company's CRO. At the same time, it should be clear where the ultimate responsibility lies for all decisions to ensure that executives and other decision-makers can be held accountable. Safe design principles. AI labs should adopt safe design principles to reduce the risk of catastrophic accidents. By embedding these principles in their approach to safety, AI labs can enhance the overall security and resilience of their AI systems. Some of these principles include defense in depth, layering multiple safety measures on top of each other. Redundancy. Eliminate single points of failure within a system to ensure that even if one safety component fails, catastrophe can be averted. Loose coupling. Decentralize system components so that a malfunction in one part is less likely to provoke cascading failures throughout the rest of the system. Separation of duties. Distribute control among different agents, preventing any single individual from wielding undue influence over the entire system. Fail-safe design. Design systems so failures transpire in the least harmful manner possible. State-of-the-art information security. State, industry, and criminal actors are motivated to steal model weights and research IP. To keep this information secure, AI labs should take measures in proportion to the value and risk level of their IP. Eventually, this may require matching or exceeding the information security of our best agencies, since attackers may include nation-states. Information security measures include commissioning external security audits, hiring top security professionals, and carefully screening potential employees. Companies should coordinate with government agencies like the Cybersecurity and Infrastructure Protection Agency to ensure their information security practices are adequate to the threats. A large fraction of research should be safety research. Currently, for every one AI safety research paper published, there are 50 AI general capabilities papers. AI labs should ensure that a substantial portion of their employees and budgets go into research that minimizes potential safety risks, say at least 30% of research scientists. This number may need to increase as AIs grow more powerful and risky over time. Positive vision. In an ideal scenario, all AI labs would be staffed and led by cautious researchers and executives with a security mindset. Organizations would have a strong safety culture, and structured, accountable, transparent deliberation would be required to make safety-critical decisions. Researchers would aim to make contributions that improve safety relative to general capabilities, rather than contributions that they can simply label as safety. Executives would not be optimistic by nature and would avoid wishful thinking with respect to safety. Researchers would clearly and publicly communicate their understanding of the most significant risks posed by the development of AIs and their efforts to mitigate those risks. There would be minimal, notable, small-scale failures, indicating a safety culture strong enough to prevent them. Finally, AI developers would not dismiss sub-catastrophic failures or societal harms from their technology as unimportant or a necessary cost of business, and would instead actively seek to mitigate the underlying problems.